Hey, what's up guys? My name is Cherno. Welcome back to my game engine series. So last time we took a look at just some maintenance talk and some of the stuff that we kind of wanted to get done before we started heavy duty kind of full steam ahead work on the renderer. Especially because I'm getting married next week and I'm just not going to have time at all. I kind of wanted to shift the beginning of the renderer to kind of after I get married so that I can just be like bam, 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 episode, 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 so that we can get a lot done without kind of having this huge gap. So because this is stuff that we need to clean up anyway, and because I've made some changes after talking about this with you guys, I just figured that it would be a really good spot for us to just get this done so that then later we don't have to come back and be like, oh, before we can continue, we should change this, or it'll be harder to change it in the future. We'll just get everything done right now. I think that's the best plan, even though I know that it is annoying for some that we just, I can't wait to start the renderer. Believe me, I'm one of those people. Rendering is my favorite part of this whole engine anyway. So I really want to be able to start that, but we have to get the stuff done. So today what we're going to do is we're going to convert Hazel to be a static library, and we're also going to clean up all of our kind of build projects, I guess. And I think there are some issues with the repository as well, because if you do like a clean check out of Hazel, I think for example it doesn't include the pre-make exe file or something like that. I'm not sure exactly what happens, but we'll take a look at this kind of stuff. I just want to get everything done so that we have those pre-make files clean and as they're meant to be, without anything extra. I think the goal really is to reduce the warnings we have right now in our kind of repository to just 0. When we build this stuff, we should have 0 warnings, hopefully by the end of this video. I don't think it'll take too long at all. And then the other major thing, of course, is just converting Hazel to be a static library instead of a dynamic library, because we talked about that last time. It's just going to be pretty easy to do, and it's just going to simplify the development so much. And as I discussed in the previous episode, I don't think Hazel needs to be a dynamic library. So because we've kind of lost that use case after some more design work went in, I think that it's just going to simplify everybody's lives, and in turn result in a more optimized application if Hazel actually builds as a static library and then links into the game. That's not to say, by the way, that we can't link modules in as like dynamically in the future. That's totally possible. Like, what you could do and what I can explore, because I know that this was like one of those things, excuse me, one of those things that people kind of brought up where I like kind of id Software's design on like the Doom engine and everything, how they have the game as a DLL that hooks into the engine kind of runs that DLL. I like that design. Maybe we can do something like that. I don't want to for simplicity's sake and because I don't think we need it, to be honest. But what I won't rule out and what we definitely can do in the future is actually dynamically load a module, a DLL, which can contain C++ code that will actually be executed as part of our game loop or anything like that. That's pretty easy to do, and we can still set up DLL hot swapping if we wanted to. All of that will just work. So that's definitely something that we can do. This design, moving to a static library, does not rule out all DLLs for the future. It just means that the core Hazel library will be built as a static library and has to be statically linked into our actual application exe file. So that's the only real thing that's changing. Let's jump in and take a look at how we can do that and just in general the state of this solution. Okay, so what I'm going to do right now is just clean this whole solution and just give it a build. I reverted all of the stuff that we did last episode. You can see straight away that we have warnings like ignoring unknown option, the C11 kind of STD, and also this linking this GDI32 layer, but I don't even know where that came from, to be honest. Like, we wrote it in the pre-make, but I don't know why. We have a lot of these warnings, which is just kind of DLL interface has to be used. Or it needs to have a DLL interface to be used, and this is from like shared pointers essentially, just because they're like template classes. And that is causing an issue across DLL boundaries. That'll be resolved because we're moving to a static library. What else is there? So we got these warnings. This stuff needs to be fixed just by declaring, just by using this macro called CRT secure no warnings. Again, if it was our code, I'd probably use the secure version of the function, which just takes in a size for the buffer so that it doesn't overflow the buffer. But because it's not our code, it's IMGUI's code, we're going to obviously trust their code and say that it's not going to fail, because that's their kind of domain. So we're just going to enable the right macro to build their code, which should be fine. If we wanted to do that, by the way, but keep in mind, there are easy ways to fix this, right? Let's take a look at, we'll take a look at these errors probably at the end because they're really simple, but I know that a lot of you might be like, And I just really want to move this over as much as possible so you guys can actually see. But a lot of you might be like, well, you know, why this whole CRT Cherno warnings thing, like why, just because IMGUI has that, why do we have to enable that for our entire Hazel project? And the thing is we don't, right? If you take a look at this, this file that's causing this is this IMGUI impl OpenGL3.cpp file. That's being built from IMGUI build.cpp because that's our kind of Unity build file for certain IMGUI stuff. We can just define that macro there, right? And that'll be fine. We don't have to define it in the project settings, in our pre-make settings or anything like that. We can just define it just there, right? Just in that file. And then that way, the rest of Hazel will still kind of have to, will still receive warnings if we use deprecated functions. So don't worry too much about that. Anyway, I think that's probably all the different ones, right? And when we have some kind of like, we have some runtime conflicts as well, like, you know, these linking warnings where this kind of default lib just conflicts with use of other libs. That's because these different DLL files or static libraries essentially end up using different versions of the runtime library, which I think should be resolved once we switch to static linking. Anyway, how do we switch to static linking? Well, the magic and all of the code really is inside our pre-make files. What I'm going to do here, just to make things really, really easy, is just search for all probably all Lua files or just all pre-make files, doesn't matter. And once I've got all of these, I'm just going to open them with VS Code. Okay, so now that we've got these open, we're just going to kind of sort through these. So we have GLFW, the GLAD one, the Hazel one, and the IMGUI one. I'm just going to put the Hazel one first, because it should be first. Let's take a look at what we have here. So currently, Hazel builds as a shared library. We just need to change this to say static library. And technically speaking, that is it. It's now a static library done, right? Now, because we're linking it as a static library, we should link static runtime. We should link the runtime library statically as well, okay? So I'll just turn that on, okay? What that means is that essentially when we build our executable, it will link in its own runtime library and that'll be it. The reason we didn't want to have this for dynamic libraries is because if we're linking dynamically, a DLL file needs to have the runtime library linked in because a DLL file is kind of like a final product. And so because of that, if we link statically, it means at build time, every DLL that we build could theoretically have different versions of the library. And that is a huge issue. Like some might have symbols on or extra debug codes, some might not. That's a huge problem. If you allocate memory with the debug version of the runtime library and then free it with the release version, that will crash your program, if not cause massive like memory corruption because they allocate memory differently. So problems like that can arise. But if this is a static library, we can link everything statically and everything should be fine. This kind of stuff, C++ dialect, that doesn't need to be a Windows specific thing really. So I'll put it under language. So we'll have kind of location, kind, language, and then language and dialect we'll keep together, and then static runtime on. So system version latest is the only thing we have kind of under Windows, apart from defines. This post build command no longer needs to exist because we're not copying DLL files after building anymore. And the next step is going to be kind of this, all of our configurations. So debug, release, and dist. So this stuff is going to say pretty much the same. I'm just going to make these lowercase because they don't need to be uppercase, just to stick with what Premake actually recommends you do in their docs. So symbols on, meaning this will be the debug version of the library. This is kind of the same thing. I think we had, or maybe I'm wrong, but I think, yeah, we had this kind of stuff, right? Which just means like link the multi-threaded, like link the version of the library that is, that doesn't have debug symbols in it, right? And that's why we did that for release. We don't need that though, because technically, oh, look at this mess. We're about to fix this stuff, don't worry. We don't need that because if you write optimize on, that's the release version of the library. If you write symbols on, that's the debug version, okay? Of the runtime library. So that's essentially what ends up getting linked. So we have this looks great. And oh, well, of course, we've got runtime release as well, but symbols on and all of that just means that we're going to generate debug symbols, whereas here we're going to optimize that code. All right, so that's fine. Runtime defines that as well. So runtime specifically meaning the C++ standard runtime, of course, in case that's not clear. Sandbox static runtime on, and we're going to again move CPP dialect up here so that we have that there. This stuff looks pretty good to me. We obviously don't need any kind of DLL copying, which we don't have anyway, and everything else looks good. I might just make these lowercase as we did before. That should be it for actual Hazel, right? Done. Yeah, that looks good to me. That's all we need. Let's move on to the GLFW one. So, we're building a static library, of course. The language is C, so we don't need any kind of CPP dialect things. These are the files we're including. And then for Windows, we don't need these flags at all. They don't do anything anyway, as we saw when we built stuff. System versions should be set to latest, and static runtime should be set to on. Interesting that that was on, because that should have probably been off earlier, but anyway. We have files, we have defined specific to Windows under here, and then again, for this stuff, we really don't need this. What we do need to do is go back into here and make sure that we essentially grab these things. I think that GLFW only has release and debug, so we just need to make sure that we'll get rid of dist, but just make sure that we basically just have the right version of the runtime and the right symbols actually set up for debug and release, so that we do have debug symbols on for debug and optimization on for release with no debug symbols. That's cool. It's also quite common to have a mix of these, by the way, where you might have optimizations on, but you still keep symbols, but we're not going to worry about kind of advanced configurations like that at the moment. Static runtime on as well, we're going to pull this up because that should be on not just for Windows, but for everything. Okay, that looks good to me. One thing I might do is just view the white space here, just because I want to, I think it's this, just because I want to make sure that everything, yeah, you see how we have spaces here and then we have tabs here? I just want to make sure that we actually have the right thing here, because if not, it can look weird on certain text editors, and also alignment will be weird. So I'm just going to make sure that we have the same kind of white space everywhere. It looks like we're using, oh great, so we're using spaces here and tabs here. We probably should just use spaces everywhere, I feel. I mean, by the way, I prefer tabs, but yeah, okay, it doesn't matter. As long as we're using the same across the file, that's really all that matters. So we have tabs here and spaces in the other one, sure, whatever. I'm not gonna worry about that now. All right, next one, glad. So again, see how we have this mix? I'm just gonna get rid of that mix because I wanna, so 1, 2, 3, 4. 1, 2, 3, 4. And I can just put that there. Okay, cool. That looks good. This is fine. Again, we don't need this. All I'm going to make sure is that, you know, static runtime we have over here, and that's set to on. And then let's see, what else do we need? We need to make sure that we copy this kind of stuff as well. So for debug and release, same kind of setup as before. I'll just leave one extra line there with no spacing, just like I should everywhere, just at the end of every file. Cool. And I think that's it. Well, I guess we'll see. And then the last one's IM GUI. This actually is in the, I mean, all of them I think are technically in the submodules, so I'll have to update the submodules as well. Like I'll have to push this code to the submodules, which is fine. That looks good, and again, you know, we'll do the same kind of thing as we did before. CPP dialect in this case goes up here, so does the fact that we're linking statically, static runtime on. Of course, this builds as a static library like it should. And again, this stuff will just be replaced by what we have here. I don't even know where I got the alt code, to be completely honest with you guys. I think maybe I just found it somewhere online and just copied and pasted, because not really sure why all of it's so different than everything else we wrote. Okay, cool. I think that's all we need. I might be wrong, but who knows? Okay, so this looks good to me right now. What I'm gonna do now is just kind of run our generate projects file. So here we go. No errors, great. And if we go back to Visual Studio and just reload all, we should see hopefully everything now set up as static. So if I look at Hazel now, it should have the configuration type static library. Again, I'm just gonna clean everything, and because I wanna do like an ultra clean as I call it, I'm just gonna delete bin and bin int directories completely, okay? So now let's build our solution and see what happens. Okay, so everything looks pretty good to me. Now, obviously, what the other big thing we need to do is actually to stop all of this stuff, locally defined symbols being imported, and all this stuff is actually just to go into our, wherever it is, this Hazel, well, let's just say application core, just go to our core.h file, which probably should be called something like base. But anyway, I think that's what it's called in the development branch. This Hazel build DLL, we're still exporting and importing, right? We shouldn't be, okay? So technically speaking, what I can do is just, like, again, as a hack or whatever, I can just hide this behind, you know, hz dynamic link and say if that's the case, then that. Otherwise, we can just define Hazel API as nothing, right? That's kind of the idea. So define Hazel API. All right. So that way, this gets defined as nothing, which means that if we look at literally any class here, this is just nothing, which means it kind of is just that, right? So that's kind of the idea. Now, obviously, if we never, ever, ever want to have dynamic linking ever, then we should just remove Hazel API completely, and then everything will just be declared like this. And that's probably something we will do in the future. I just don't want to waste time right now, like search and replace everything. I mean, it's not going to be too difficult. If you guys want to do this, you can just do Hazel API space and replace that with literally nothing, and that will just clear all the Hazel APIs. That should work generally well. I don't think, I mean, apart from maybe in here, you'll have to do additional work, but everywhere else that should just work. But what I'm going to do is just, again, just clean the solution after this and build everything. Okay, look at that. So this looks a lot cleaner now because we don't have those errors about the DLL interface stuff. And we don't have those warnings, sorry, not errors, warnings, but we also don't have the warnings from, you know, the wrong kind of command line options being used, which is great. So the only warnings we have left, and we can look at the error list to make sure. Oh, well, there's this one inside our GUI layer where we convert from unsigned into float. So we can just add a little float cast here to fix that up. Let's do another build. There you go. We might have to rebuild. We might just have to rebuild Sandbox so that we get those original warnings back. Okay, there we go. So now we've only got 3 warnings left. And this stuff, what we could do is we just need to, again, have this macro. I'm not sure if you guys can see it all the way off the screen there, but basically this file is using functions like these, not the _s kind of secure version. And because of that, they're deprecated, and because of that, it's generating a warning. What we could do is, of course, to kind of fix that, we could go back into our pre-make files and make sure that Hazel defines, where are our defines? I mean, we don't have any defines, oh, this is Sandbox. We don't have any defines, I think, for all platforms. It looks like we've only got defines for Windows, but in the all platforms one, we'd have to basically add CRT secure no warnings. We could do that, that's one solution. But since I do want to kind of enforce that we don't have deprecated functions everywhere else, I mean, we still might, we'll see, because to be honest, I don't really use the secure versions much. I usually use the normal ones. But maybe going forward, we'll try and use the secure ones. Because of that, I can just take a look at where this file is being built from, which is imgui build.cpp, because it's like our little Unity build. That CPP file, the imgui one, isn't being built separately. Like by itself, I mean, it's not being fed into the compiler. If we go into imgui build.cpp, I can just define that here, right? And then that will obviously only apply this define for this translation unit after this code kind of gets pasted in. So that way, you know, we're not kind of deprecating it everywhere, right? Or rather, we're not allowing this code everywhere, just in this file. We're just suppressing the warning there. So I'll do a rebuild of everything now, and hopefully we should get no warnings. Okay, so somehow we still actually get them. That's interesting. We definitely shouldn't. The only thing I can think of is maybe the functions that are including them are probably coming in here. So we might have to just drag that up before our PCH file. Let's give that another build. But of course, if we do that, we can't do that because it's a precompiled header, which I forgot about. So this is actually turning into a little bit more of a problem than I would hope it would be. So I mean, it defines it here. It's supposedly supposed to define it here if we actually look at the source code, but it doesn't in this case because we've got it defined. So actually we shouldn't even need it, technically speaking, because see, now it's being defined. However, it's still causing problems. And I suspect that's because our precompiled header is already including the stuff that it shouldn't be. Or rather, it's already including functions that have that, because you can see this declaration is actually inside string.h, which of course is being included before. Like it's being included inside our precompiled header. So technically speaking, again, if I go to hzpch and before string or whatever, I define that, that should actually take effect here. Or maybe we'll have to define it even before that. I don't think IOStream defines that stuff. So that's a little bit weird. But if we look at this, yeah, there we go. So ImGUI build actually builds there, and we don't have anything. But unfortunately, that's kind of the same, like, we disable it everywhere, not just where it's used, which is a little bit annoying. I thought that maybe, but yeah, obviously it makes sense that it would disable it everywhere, either everywhere, not based on usage, because obviously that deprecation flag, the compiler attribute for deprecation, is actually there when the function itself is compiled. It's not used like based on templates or anything like that, like it might be. Anyway, so we either have it there, or I guess the correct thing to do in this case would actually, in fact, to go to my first, to do what I did in my first kind of solution, and that's just to add a define here for all platforms, where we just do CRT secure no warnings. So there we go, and I'll just make sure, yeah, we've got tabs everywhere, good. And now if we just regenerate projects, go back here, reload everything, I'll clean again and do a build. We should have 0 warnings finally. And this now would probably be a good time to turn on warnings as errors or something like that if we really want to keep this building tightly, but I probably won't do that because that might get annoying. Okay, there we go. Everything succeeded. No warnings, no errors, nothing like that. Wonderful, it's nice and clean. And if we launch it, everything of course should work. And there we have it. Okay, so that is pretty much it. All right, so that's pretty much it. If you guys enjoyed the video, please hit the like button. Also, a huge thank you to all the patrons that make this series possible. I'm gonna be away for like the next, I don't know, 2 to 3 weeks, we'll see. Hopefully, I should have time to maybe make a video next week because I've taken the week off work. So maybe if the wedding stuff doesn't get too much in the way, which obviously it might, and obviously I'll prioritize that. I don't wanna promise anything, but I might make a video for 2 weeks from now, we'll see. But apart from that, I'm going to be away for a few weeks. So, if you do want to if you don't want to just let this sit here, then if you support the series on Patreon, you can get access to the development branch, which has a lot of this kind of renderer stuff already done. So if you want to kind of jump ahead, or if you're kind of doing stuff on your own, but you want to see how I do it, or you want to just see if kind of you've done it the correct way, or how we're intending to do it, then you can definitely check that out. And also it'll really help support the series, which is great. I can't wait to be back for you guys. And we can finally get onto the renderer stuff. So yes, hope you guys enjoyed this video. I will see you next time. Goodbye.